My name is Augustin, I am a composer and music designer. In this video, I'll explain how I compose and design the music for this indie project called Childmare using Wwise and Unity. Childmare is an atmospheric adventure game that depicts the fantasies and fear of a child. Players will go on a journey through his dreams and nightmares, which unfold in a playful world. Because the game is about childhood and play, I decided to incorporate some children's instruments into the composition, such as a triola, a small xylophone and metallophone, an ocarina toy, among others. The aim was not to have a purely childish aesthetic, but a few elements that offer a more consistent sound with the overall tone of the game. For the design of the music, I'm going to focus on the first level, the Western level. First of all, I need the general music of the level not to be repetitive and include enough elements and variation to avoid being redundant. To do this, I divided the music playlist container into 4 distinct parts. The introduction, which will only be played once at the start of the level. And parts A, B, and C. Each part is different but totally adaptive with the other. So we can play part A and B and C, but also B, C, and A, and so on. Now, when you look at each part individually, you can see that there are several tracks. Low instruments, percussions, piano and marimbas, strings, woodwind, etc. And that each track itself contains 2 to 3 variants using random step subtracks. All these parameters provide an effective modularity that allows the music to be coherent, but not identical on each playback. In Unity, all I had to do is create a box collider, import an AK state, and define which state I wanted to use. I added an AK trigger enter and choose my player, as well as an ambient AK with the event I've created for the music. Now let's see how it looks in game. In this Western level, there is a sub-level called the Mines. The Mines have a more gloomy atmosphere, so I had to write a different soundtrack to match the new mood. Using the same principle as in the first level, I wrote part A and B, each with several instruments and variations. The 2 music playlist containers, Mine and Western, don't have the same tempo or the same tonality. So I had to write transition segments to make the music flow. I then had to manually create the input and output custom cues for each segment of the Mines and the Western to tell Wwise when the music should transition. Then, in the transition tab of the music switch container, I associated the different segments with each transition. The final step was to create a new state group comprising the Mine and the main Western states, and associate the corresponding music playlist in the music switch container. Let's see the result in Wwise. Within Unity, all you need to do is to create new box colliders and assign the corresponding AK states. After this simple transition mechanism, I wanted to add a bit of depth to the music system. The level has a large saloon with a piano, and I wanted to take this opportunity to add more detail to the experience. The aim was for the piano in the saloon to play the non-diegetic music in real time as diegetic. The 2D music becomes 3D as you approach the piano. The first step was to create a ragtime-ish version of the level's music as if it were being played on a pneumatic player piano. So I recreated a music switch container similar to that of the level's main music, incorporating the three revisited parts A, B, and C. The next step is to divide the music into two different buses. Diegetic music, the piano as 3D object, and non-diegetic music, the one we listen in stereo. On the diegetic bus, I first applied a reverb to give the saloon some acoustic consistency, and then I applied a meter effect where the output is connected to an RTPC called fading RTPC. I then had to apply a volume automation to the non-diegetic bus with the RTPC I created. The desired effect is simple. The closer you get to the piano source, the higher the piano signal will be, influencing the RTPC signal and attenuating the non-diegetic music. All you have to do is adjust the RTPC curve, create a sphere in Unity, and add the event corresponding to your diegetic source. Let's see the result in Unity. The last mechanism is less complex but just as effective. The final zone of the level is a canyon. So as a player, you will have to climb over the rock formations to reach your goal. My idea was that the closer the player gets to the top of the canyon, the calmer and more peaceful the music becomes, in a tone evocative to the lone cowboy contemplating his ranch. To achieve this, I proceeded in a manner similar to the previous mechanics. First, I create a calmer, cleaner and more soothing version of the music. I then split the non-diegetic music bus into two buses, high altitude music and normal altitude music. Finally, I created an RTPC called Altitude that lowers the normal version of the music at the same time as the soothing music is raised as we get closer to the top of the rocks. To complete this, I combine the two music switch containers, normal music and altitude music, into a single event to keep the two music in sync. Now let's see how it goes. Back in Unity, I needed to find a variable that gives the position of the player on the y-axis. Then create a script to assimilate the RTPC to this variable and attach this script to the player object. Let's try. And that's all for this video. Feel free to give me feedback or point out any errors. I had a lot of fun working on this game, and I hope to come back soon with even more interesting music and designs.